In this video, we are going to talk about an introduction to experimental designs, and I'm calling this part 1. Stay tuned for part 2. Now, at our school, and I'm sure it is common in many schools, the goal of increasing SAT scores makes a school look good. And so, what school wouldn't want to increase their SAT scores? So, a common strategy that schools have is to offer an SAT prep course, or maybe an ACT prep course if your school focuses more on the ACT rather than the SAT. Now, let's say we have 100 juniors signed up for this SAT prep course, and they're going to take it 2 hours a week for 6 weeks, and it doesn't cost them a dime. School really wants these kids to get better SAT scores, so why would they charge them money, right? So let's offer this to them for free. And even the icing on the cake is they're going to randomly select a student each week for those 6 weeks to receive $50. I mean, how great is that? This thing doesn't cost you anything to do, and you could potentially have the chance to win $50. Sure, why not? Now, here was the ultimate result at our school, that those who took that SAT prep course, those 100 juniors, their mean SAT score was a 1230. And the students who did not take the prep course, their mean SAT score was 1080. So we have a 150 point difference between those two groups of students. So is our conclusion that taking the SAT prep course will cause your SAT score to go up? I mean, right? That's what we can conclude, right? Taking this course, I mean, there was a 150 point difference between the two groups. But we can't automatically assume that that's true. So what we just observed, no pun intended, is an observational study. And in an observational study, we observe individuals and we measure variables of interest like SAT scores, but we don't attempt to influence the responses. So we offered this course and we just let whoever wanted to sign up for it. We didn't force anybody to take this SAT prep course. We had students volunteer their own time and effort to take this SAT prep course. So they were volunteering themselves for this. And so we weren't really active participants. We didn't force people to do this. So an observational study can find a correlation, boy, that sounds awfully familiar, like it was from last chapter. They can find a correlation between an explanatory and response variable, but this correlation does not imply causation. So we can see a relationship between two variables, but we can't necessarily say with certainty that the explanatory, usually our X variable of interest, does not necessarily cause the effect that we're going to see in our response variable or our Y variable. Okay? So we talked about some examples last chapter of things that were correlated, but really didn't make sense that they would be correlated. So it's really that along that same lines of what we're talking about here. Now, confounding variables. We talked about lurking variables last chapter, but now we're going to talk about confounding variables. And they're very, very similar to each other. But lurking variables from last chapter, those were unknown variables or factors that might kind of get mixed up in our results. Confounding variables are known variables or factors that might explain a difference in your response variable. In this case, our SAT scores. So if we consider some things that might be confounding variables, like maybe the $50 is motivation for students to take this course. Maybe overall they just have a higher motivation level, right? Students that just want to do well. They're A students and they want to do really well on the SAT. Versus students who don't sign up, maybe they're not highly motivated. Maybe they could care less what they get on the SAT. We could have students that are college bound. Those that want to get into any kind of elite college. They have to have a certain SAT score to get in or to get a certain scholarship to go to this college. So they may be more motivated for a variety of reasons, whether it's monetary, just overall, it's your personality that you are a very motivated person, or it could be college related, why they are motivated to do better on the SAT. Now, with confounding variables comes confounding. Now, confounding is when it's unclear if the explanatory variable or variables, depending on how many we're talking about, and or the confounding variable or variables, depending on how many we're talking about, led to a change in the response variable. Okay, so it's unclear how much of what we saw in the response variable was because of the explanatory variable and how much was really because of the confounding variables. So it's like we've mixed together these two pools together, and we don't know how much of each is really contributing to what we see in the response variable with those differences in SAT scores. So here's a little kind of outline of what we currently have going on right now in our observational study. We have our explanatory variable, we have our SAT prep course, and over on the right side we've got SAT scores, which is our response variable, and we are currently seeing there's a correlation. We see that people who do take the SAT prep course have higher scores. Those who don't take the SAT prep course, on average, had lower scores. But we talked about how these confounding variables might be contributing to that. That there's really these confounding variables in between our explanatory and response variables, and they may be having some effect on our SAT scores. Now, ideally, what we want to show is that our explanatory variable is causing the increase or decrease in our SAT scores. But again, just because we see a correlation does not necessarily mean that that matches with a causation as well. So how can we show causation and not necessarily a correlation? We're going to have to step up our game. And to do that, we're going to have to take an experiment. So an experiment is where we will deliberately impose a treatment or maybe treatments on individuals or subjects in general to measure their response or responses, depending on how many response variables we have, while hopefully reducing or eliminating any confounding variables. So it's really tough for the lead person who's going to do an experiment to consider all of those confounding variables and then try to minimize as much as they can or try to eliminate altogether how those confounding variables might introduce bias and introduce results that we aren't for sure if it's because of the treatments or if it's because of the confounding variables or some combination of. So this is ideally what we want to see. We don't want to just have correlation. We ultimately want to have causation. So this is what we're going to do. We're going to try to eliminate or reduce those confounding variables so that we have just our explanatory variable that is causing a change in our response variable. That's the goal with an experiment. So to do a proper experiment for this scenario, so we're going to break this down into kind of three areas here. First, we're going to start with our subjects, which formally are called our experimental units. Now, experimental units could be people, and I would say for the most part, that's usually people. And if we have people as our experimental units, we would then call them our subjects. All right, so subjects are human experimental units. But we don't always have to do experiments on people. We could do experiments on, plants or animals or anything, really. And so just in general, experimental units are who or what you're going to do an experiment with. Now, ideally, we should randomly select these people from our population. And if we were only going to focus on juniors taking the SAT, then ideally we should randomly select our 100 juniors from the junior population. Again, a proper experiment. This is what we should do, is randomly select them. Now, speaking of random samples, depending on if your sample was random or not, there are some takeaways from those two things. So let's say we did take a random sample. What we are allowed to conclude at the end of our experiment is that the results will apply to the whole population that the sample was taken from. So if we randomly select our 100 juniors, then that means whatever results we see from our experiment may apply to all juniors from our school. So what does that mean if we don't take a random sample? Well, then that means that the results only apply to those students who were in the non-random sample. Okay, so if we only had, let's say, 100 junior volunteers, then the results that we find from our experiment only apply to those 100 junior volunteers. Or, this is going to be more for my AP exam people, or it will apply to people that are similar to those in the non-random sample. And now this gets a little kind of hairy here, because how do you really define what kind of people are similar to the people that were in the non-random sample? And that's kind of difficult to kind of pinpoint exactly. And so we could talk about similar characteristics involving, who knows? I mean, we could be talking about GPA or class loads or whatever the case may be. Lots of different ways we could define similar in that sense. And it really depends on the context of the problem. Next up in our experiment, let's talk about the actual treatments that we are going to be imposing on our subjects. Now, in general, if we're going to talk about treatments, we first need to talk about the explanatory variable or variables slash the factor or factors. So these are kind of like the main things that we're going to experiment with as the treatments. And so we really only have one specific treatment in our experiment, and that is the SAT prep course. Now notice below this I've got levels, because we really have two different levels that we're going to do with our SAT prep course, and I'll talk about that coming up in the next slide. Now, the combination of all of the different factors with all of the different levels give us our overall treatments in that experiment. Now, I mentioned previously that we have just one factor in our experiment, which again is the SAT prep course, that can be broken down into two levels. And our two levels are that some students will actually take the SAT prep course, and some students are not going to take the SAT prep course. So just because we have one factor that is broken into two levels, it's really just these two levels that represent our overall two treatments in our experiment. Now, when we have our students who take the prep course, we need to control for the confounding variables. So remember those confounding variables we mentioned earlier, like monetary incentives, or maybe these kids are just overall more motivated, or maybe there's college bound or college motivation going on there. The only thing we can really try to control for, and if we randomly select our kids, we're going to have some kids that are motivated and some that aren't motivated. So we'll naturally already have both groups there. We'll probably have some kids that are going to go to college and some that aren't going to go to college. So we've already kind of naturally taken care of that with a random sample. But the one thing that we can control for is the $50 a week that students could randomly win. So maybe in our experiment, we don't offer the $50 incentive. Okay, so let's get rid of that. That's a confounding variable. Let's control for it, and let's eliminate it. Now, the no prep course, they don't actually get a treatment, right? I mean, they're just going to live their lives like they would have normally. So what we would call this type of group is a control group, and they're going to provide us a baseline comparison to our group of students who actually took the prep course. Okay, we don't just give kids the SAT prep course and then look at their overall score, and then we have nothing to compare it to. So our no prep course is going to be what's called our control group. To determine how many total treatments there are, we're going to have to really think about how all of these levels from all of these factors really are going to blend together here. So I'm going to start off with, let's say, treatment 1. And in treatment 1, we're going to obviously cook our cake, bake our cake at 350 degrees, but maybe we try the 2 cups of sugar with the 3.5 cups of flour, with the 3 full eggs, with a 1.5 cups of milk. And we bake all that at 350, and then we see how it came out in the end. And there are different response variables that we could really measure for how good that cake is. But this could be one of our treatments. Now, treatment 2, we would want to just change one little thing. And so let's say we still do 350, we still do 2 cups of sugar, we still do 3.5 cups of flour, we still do 3 eggs, but instead of 1.5 cups of milk, what if we now do 2 full cups of milk? And then we bake that cake. So there's a second treatment that we could look at. Now, the final treatment, and then we'll talk about how many we can actually get here. So the final treatment would be obviously still doing 350, but now I'm going to get to all of the kind of last scenarios here where I've got 2.5 cups of milk with, or not milk, 2.5 cups of sugar, 4 cups of flour, the 3 eggs plus the 1 egg white, and with the 2 cups of milk. Now, again, I didn't say what treatment number that was going to be, but if you want to figure out how many treatments there are altogether, you really need to look at the number of levels that you have for all of your factors. So this is something else that really is not related to this entire chapter, but if you want to figure out the total number of possibilities, and in this case the total number of treatments, you need to multiply all of your different levels together. So in terms of the oven, in terms of heat, there was 1 level, times how many different levels did we have for sugars? We had 2, times flour, we had 2 different. For eggs, we had 3 different levels. And for milk, we had 2 different levels. And so we multiply all of those out. And so 1 times 2 is 4, times 3 is 12, times 2. There's really 24 total treatments. And again, it's all that mixing and matching of the heat with the sugar, with the flour, with the eggs, with the milk. Now, again, we're not going to do anything near this crazy in terms of 24 treatments. Usually at the most, we're doing maybe 4, 5 treatments at the most. And it's usually just maybe one factor split up into 5 levels. But I wanted to show you a more extreme version of maybe a cooking experiment to really understand the ideas of how the factors and the levels produce all of those treatments. All right. So going back to our treatments, we had 2 levels for our one factor. We had the kids that were in the prep course and the kids that weren't in the prep course. And if we randomly select 100 students, we would ideally split them up 50-50, literally 50-50, usually 50%, 50%, but that's 50 juniors and 50 juniors. But ideally, we should randomly assign 50 juniors to take the SAT prep course and technically randomly assign the other 50 to not take it. So depending on if we randomly assign to our treatments and to our factors and our levels, there's 2 things that we may conclude from. If we randomly assign our people to treatments, then the results may imply a causation, a cause and effect relationship. But if we don't randomly assign, then we cannot automatically imply a cause and effect relationship. We could maybe see correlation between the 2 things, but we can't say that one causes the effect of the other. And if no, then we introduce back all of those confounding variables that may contribute to differences in SAT scores not related to taking the prep course. So yeah, if we let kids decide, do you want to take the prep course or not take the prep course? Again, all those students who are maybe college bound or they want a really good score to get into a certain college or maybe they're overall highly motivated, they're going to be the ones that'll take the prep course. And those that don't meet any of these criteria, they're not going to take the prep course. So we want to randomly assign. And again, you might be like, well, that doesn't seem fair. That seems like we're doing something against their will. Yeah, kind of. It does kind of have that feel to it, right? All right. Last but not least, on the third part here, our response variable, which was measuring the SAT scores. In the end, we want to compare the SAT scores of our 2 groups, the group that took the prep course and the group that did not take the prep course. So overall, this is ideally what we want to do. We want to have our subjects, and we want to randomly select them. We want to have our treatments, but we want to assign our subjects to however many treatments that we have, however many groups that we have. And in this case, it was just 2. And then in the end, we want to compare our SAT scores. So we're going to get more in depth into this. Like we're going to draw an outline, if you will, a map of an experiment. So an example to end with here. And this is a legit actual example. You can look this up. I'm not making this up. This actually legitimately happened. A group of researchers in Africa found a creative way to protect cattle from lion attacks. They painted eyes on the cows' rear ends. To determine if this treatment is effective, they randomly assign 2,100 cattle to one of 3 treatments. So on some cows, they painted eyes on their rear ends, like this picture over here on the left. Like you can kind of tell those look like eyes. And then they painted just cross marks. They put X's on the butts of some cows. And then on other cows, they just left them alone. No markings. And after 4 years of living a normal cow life, the cows with eyes had 0 deaths. No lions attacked those cows. But cows with cross marks or with X's, they suffered 4 deaths. And the cows with 0 markings, there were 15 dead cows from lion attacks. So taking this into consideration, I have a whole sequence of questions for you to answer as a part of your you-do problem. Number 1, is this an observational study or an experiment? And tell me why. Number 2, what are the experimental units? Number 3, how many factors are there? And tied to that, how many levels are there? What purpose does the no markings group provide for us? What is the response variable? To whom do the results apply? And does this show correlation or causation? So try those out, and we will discuss all of those in depth the next day in class.